All right, guys. Thanks for tuning in if you're still here with us. Can they hear me?
Yep, they can hear you loud.
All right, good. If you're still with us after those technical difficulties, bear with us, please. It's RITSEC. All right, guys. But I am here to give you a presentation on behalf of the RITSEC Physical Security Interest Group. Tuesdays from 1 to 2, and it is going to be about kind of an evolution of lock picking and anti-lock picking measures as they increase in hardness or whatever. Okay, wait. I hit the arrow key. Space. It's not.
Click on the PowerPoint.
Okay, I think I went before. All right. So, as you might be able to tell, I put a lot of time into this intro slide. It was just basically the thing that I worked the hardest on in this presentation. But a little bit about me. My name is Loudon. You may know me from like being at clubs sometimes, but I wouldn't blame you if you didn't. Third year CSEC major, founder of the RITSEC Physical Security Interest Group. Let's go. I'm from Cleveland. I like cars a lot, so like if any of you like cars, I would really appreciate just like other people who like cars, want to talk about cars. I'm your guy. And oh, how did that get in there? Future? No. People will know that he's my favorite rapper ever. Guys, this is my dirtiest secret. Please don't tell anyone. Right. So RITSEC Physical Security Interest Group, this is kind of like a long-running, important thing with our club. We have a, am I off of camera? Oh, you gotta adjust it there? Right, so I know RITSEC has their own like disclaimer. You maybe said it this week, but basically I'm gonna tell you some stuff that could be used for like theoretically criminal things, so don't do that. If you don't own the stuff, don't try to fiddle with it. You'll break something probably, like most likely. I mean, just don't do it. Bad idea. Bad luck. Bad luck for RITSEC Physical Security Interest Group, and nobody wants that. So, yeah, just refrain. So here is, oh no. Guys, we were having not enough technical difficulties.
There you go.
I just wanted to move the screen back, and I like blipped the cable, and then it disconnected, so I'm gonna not do that again. But how a pin tumbler works, we're gonna be focusing on pin tumblers for this talk. There's a bunch of other types of locks that we go into in more depth in the actual interest group, but for the sake of brevity, we're only going to be talking about pin tumblers. Here we have an animated little video here. I'm gonna refrain from using the three-letter acronym for those for obvious reasons, but this is, you could just see how it works. You got some terminology here. I'm gonna walk off screen. For those who are in the audience, like it just so they can get a better experience, obviously, like come in person and this wouldn't be a problem. Anyway, so as you can see, the key actually moves the key pins here up and down to a point where they move the driver pins, which are these upper pins, out of the plug or core or whatever term you want to use for this center bit that rotates. And the key moves those out to all of their specific heights. These are different heights. These are generally the same height, the driver pins. And then springs, usually all the same, but sometimes they can be like different. Spring like pressures makes it a little tougher. It's like challenge lock territory there, really. But yeah, shear line here. This is where all the pins have to line up at if you want to be able to open the lock. And was that clear, Jake? You think that was enough to understand how one of these works? Yeah. Probably good. Anyone paying attention?
Fantastic.
God, tough crowd. Anyway, so how can we exploit that, right? As the hackers we are, we're gonna have to figure out exactly what to do to make these open at our will. So this is tensioning. This is what it does in concept. Which I have pictures of actually what you're doing to tension the lock in the next slide. But what you're doing is you're taking this core with no key in it, and you're trying to turn it, and this will bind up one of these pins, and I'll talk about why it's only one, because if you saw the animation, you would think it would be clamping on all 5 of them, or 7, or whatever was in that picture. But it's only one, and that's why we're able to pick them. You see, it will bind up. It will be caught between the core, the hole drilled in the core, and the hole drilled in the Bible or the body of the lock here. And thus, it will be unable to come back down once you push it up. It'll be kind of firm when you're in there messing around with actual tools, which I'll get into in a second. But this is tensioning. You are putting a force on the core, a rotating force that clamps one of the driver pins and holds it there. So this is how you actually apply that force. You have 2 different styles of tensioning tools. This is just like a metal bar. You can make these out of like windshield wiper inserts for like free pretty much. But basically you just stick that in the bottom of the lock. It works all right. It's kind of restrictive, and I'll probably touch on this later, but there's only a limited amount of space in the keyway, and having something like that at the bottom can... You got a question?
How do I know which way to apply the tension?
So generally they'll open either way, and if you're just doing it for, well, if it's a core like this is like a residential cylinder, there's no mechanism actually connected to the back. Am I being too quiet?
I think you're a good volume.
All right, cool. So yeah, with residential stuff like this, you need like a mechanism connected to the back in order for it to actually actuate anything. But generally, the way that they pick is like, is that clockwise, like this? Yeah, kind of like that. I don't really know, but yeah, here's the top of the keyway tension wrench. As you can see, that one's being turned in that direction as well. But yeah, these are like door cylinders. Padlocks tend to open just that way, the clockwise direction. But yeah, this is top of the keyway. You can see there's a lot more space here in this grainy image for you to put other tools, which I believe are on the next slide. Yes. So these here, this is like a side view of those tensioning tools that were mentioned in the previous slide. And these are our tools of the trade, the picks. We got the hook on top and the rake on the bottom. I'm not really going to touch on rakes this talk, but just know that they exist, and they work by basically trying to randomly shake up all the pins on the inside of the lock so that they align with the shear line. Basic concept. There's a little bit more to it. There's a lot of technique along with it, but that's how that works. But the hook is what you really want to focus on. Let's see. Let me see. Oh, yeah. So we want to stay on this slide for a while because this takes a while to cycle through. But what you're doing is you're kind of sticking it in there, going along the bottom. You don't want to interact with the key pins too much. And you're feeling for one that is bound, as I was talking about earlier, because one of them will be bound. And I don't know, it's kind of grainy because I stole this off Google Images earlier. But that little yellow thing on top of the blue pin, that signifies that it's binding. And as you can see, the ones that are binding, they move up and they don't come back down. I also have an image in here on the other side of the slide about binding order, which is what I was talking about, how only one of them binds at once. That is because of manufacturing defects. The holes in the core and the diameter of the pins aren't exactly like 100% uniform, and I don't think they really can be. So like one of them binds at once, and once you've picked one of them, the core will slightly rotate, and then you can go on to picking the next one. And that is how I believe these are all the slides I have dedicated to traditional lock picking with no countermeasures. And I think that's cycled through a couple times if you've been watching. But like I was saying, the general technique, you go through and you look for the binder, and that's the one that's going to be tough to move. All of the other ones should be springy, like it's showing. And once you find that, you kind of lever the tool against the bottom, and you kind of hold it like a pencil. This is kind of a gripe of mine, is people holding them in weird ass ways, because you want to make sure you're holding it correctly when you start off, or else you'll be holding it all weird all the time. Anyway, that's what you want to do. That's the basic theory. However, oh yeah, and then this is where you've probably seen some of these locks before. These are a variety of form factors of said traditional pin tumbler locks. This is the ubiquitous Master Lock number 3. You've probably seen one of these before. If you've gone to ShmooCon or whatever that stuff, you probably are like somewhat familiar with what I've been saying on these previous slides, and you probably picked one of those. So the next stuff after this is kind of more for you. But yeah, you have mortise cylinder, kick cylinder. This is more for like traditional deadbolts and older doors. Kick cylinder, this is for like door handles. Usually you wouldn't see this part of it. You're only going to see the face of either of these anyway. This is like a newer style deadbolt. That's a rim cylinder. But these are all residential. 5-pin, like maybe Schlage? I don't know. I can't really see the Keyway that well. But locks there. And you've probably interacted with them numerous times in the past. And here is a slide the likes of which I am going to gloss over like crazy, but we have some other locks you've probably seen. This is a disc detainer, most commonly found on like bike locks. These two are most commonly found on filing cabinets. That's a fucking tubular lock, and that is a wafer lock, and this is an SFIC lock. It kind of behaves like a traditional pin tumbler, except it's got a bunch more stuff going on inside of it. This is, if you see a lock around campus, it's probably going to be one of those. So I think we have a whole week that goes into those. They're really interesting, but basically, you know how I was talking about the shear line before? Those have 2 shear lines. So yeah, get ready for that. But yeah, so at some point they wisened up to all of us, deciding to pick these locks and started throwing in some countermeasures. This here is the most basic form, a spool pin. And this is a pin that has been ground down around the center into sort of a, I don't know, dumbbell shape or something. But basically what happens is, as you're going along on your merry way trying to push up all the pins that are binding, one of them, or once you get rid of all of the regular drivers, right? So we're talking about binding order, the core will rotate far enough that it is now binding on that thinner section of the spool pin. And as you go to push that up, it's going to get caught, as you can see from the little animation there that I stole and probably should give credit to, because they're really nice, honestly. They might be tools, I forget. But yeah, so those will catch on the shear line and cause it to give you a bad time, maybe if you're not so experienced. But generally, you can tell if they're in there. You will just push up. The way that you defeat these, right? So you're picking and you go. You've fallen into what's called a false set, and that was what I was talking about earlier, where you are clamping the thinner bit of the spool left, and there are no wider driver pins left in the actual lock down. And then so that's usually characterized by the core turning like it's going to open, but like only a little bit, but substantially more than when you pick like one pin. Right. So the way you deal with those is you go through and you push up on all of them, and one of them you push up on it, it's going to counter rotate the core. And as you can see maybe from that animation, like near the end, how the core starts to counter rotate, you could probably get a good idea just from the picture of how it would actually turn backwards when you go to push up on the spool. but that's what happens. You just kind of got to get a feel for that, but the general theory is you just search for it, and you'll know which one you're pushing on when you feel it. But yeah, and then this here is a Master Lock 140. The club has some of these. Our RITSEC Physical Security Interest Group has like 3 maybe? I don't know, but they contain like 1 or 2 spool pins. It's like a 4-pin Master Lock, brass construction, fun times. Briefly touch on mushroom pins here. This is a lot of the same theory as spools, but like UK, I don't know, pretty much. Like they're just more common in Europe. Same deal, really. Serrated pins, also the same concept. They just like put a bunch of smaller serrations onto the pin that cause it to get caught on the shear line as you move it up. And if they're feeling particularly dubious, they can put them down here on the key pin as well, so you can overset. That's the term for moving the key pin up here where it should not be when you're picking. And you can overset it and then be caught in a serration up there on the key pin, which is fun. Yeah, so these are Master Lock 1100 series. Here, I've actually brought some today if we have a lot of time. How am I doing on time, by the way?
It's like 20-ish minutes in, 15 minutes.
All right, that's pretty good. Keeping up a decent pace. I've only lost like, I don't know, maybe 1 person? I don't know. Anyway, so serrations. That's what they do. They kind of get caught up in a bunch of different places. They're real clicky. These ones, it's kind of like, it's not as drastic as a spool when you get caught on them. So you just kind of like click around in there. You can tell when they've set and whatnot, like a normal driver. But it's just a lot of getting to get the feel for it, putting in your time. But this is another thing, serrated spools. I know I mention these sometimes, but those American locks that I showed on the previous slide have some of these as well, like 2 or 3 per lock. I forget. It's like a 5-pin lock, but it's just I mean, if you could see from this terrible picture, it was actually surprisingly hard to find a picture of these on Google. It's just a spool, but they serrated the ends, so it's like even more secure. This is another thing to note. The actual profile of the key can have an effect on how easy the lock is to pick. This on the side there, like, just imagine trying to get tools in there, you know? It's a Medico key mark. These are the 2 most common ones up there, a Schlage and I think I said that backwards, a Schlage and a Quickset. And those are the 2 most common residential, like, lock key types. Yeah, so basically, you just have to take into account, like, the space inside of the keyway that you have to work with and what tools to use. You can get a bunch of different ones. Very specialized tooling for this, and then I have a picture down there of like key control, which is a more advanced concept, but basically like some keys will fit in like a lot of different types of keyways, and then some will not. So it's like master keying, but with the actual form factor of the key. This is a graphic I decided to throw in here. This is just like more front cutaway profiles of the lock that show you different attacks, binding, underset, set, overset. I've been over all of this. Security pins, this is just a bunch of spool stuff. These are some interesting things to go over. These do directly apply to picking. There are some pins that will, or pin stacks rather, that will fit entirely within the core and you won't actually have to pick them. So I guess that's possible with a 410 master lock, lockout, tagout lock. I can't really read what that says, but that's an overlifting attack. That's when you push both pins up into the top of the lock. That's possible on some locks. You just get this comb-shaped tool that sticks in there and pushes all 5 of them up, and then you can open the lock. Then there's a zero rest key, or a zero rest pin, zero lift pin, and an example of master keying, which I will not be getting into in this talk. And so where do we go from there? All that's well and good, but it can all be picked with ease if you've gotten used to it. Then there's, of course, high security locks. I'm going to kind of glaze over this, but the general concept of this here, this is a classic Medico biaxial. This is like a corporate type, or I don't know, industrial? What's the word? Cylinder, and it's a mortise cylinder form factor, obviously. And the big idea here is, with this, the pins just go up and down. If you can see these little axes marked on the key, the pins in a Medico actually rotate as well. So they must be, it's like probably 30 degrees of rotation, but they get set in rotation by these cuts in the key, and they don't come to a point like the other key pins. They come to like a kind of a straight line that interfaces with those, and that puts them all in the correct rotation. And the reason that works is there's like slits cut down the side of the pin that interface with this sidebar, which is kind of comb-shaped and sticks through the core. I don't know how well you can see it. I'm not really sure what this graphic is from, but it's not super great. You can see the slits there, and then the comb type thing like there. There's also some like anti-drill stuff in the front because it's high security. But that is the Medico biaxial in a minute, or however long that was. Just hoping to pique someone's interest so that they will please come to the RITSEC Physical Security Interest Group. And questions? I know you had one earlier. Any from anyone else? Anybody? Come on. Were you listening? What's the stream say? Anyone got shit on the stream?
No, I'll double check. You just do such a good job explaining Loudon.
I'm talking a mile a minute. What's up? Jake, please, this better be a good question. We don't got time for many more questions.
Boy, oh boy, it sure does sound interesting. Where and when can I learn more about this stuff?
This is not scripted at all. Anyway, this is how you get to the RITSEC Physical Security Interest Group, RITSEC Physical Security Interest Group. It is in Workplace, if you didn't know, but like you're probably on there, you've probably seen it. Anyway, it's from Tuesdays 1 to 2 p.m. in Golisano 2690. It's like the second floor, you know, over by like the that area with all the chairs and stuff, kind of opposite of the cyber building entrance. It's right over there. And the biggest draw for this is we actually have lock picks that you can play with. If any of this was interesting to you remotely, you don't have to invest any money. In fact, I would advocate that you not until you come to the club and we can inform you on what is and is not like good stuff to spend your money on. So we have supplies. You can come out, play with our locks, play with our lock picks. We got some new stuff in recently, like tubular lock impressioning tools, more stuff for tubular locks. Basically, a fun time overall. The boys are always there. Come out. I have no more slides. Anyone want to see me pick a lock?
Yeah, we got time for a quick demo. Do it.
All right. I was like sort of rehearsing this before, so we'll see how well I can do this like under pressure now. I'll get in front of the stream camera if I can.
Yeah,
Shit.
here, we'll get you nice and close, Loud.
Oh wow. Nice and personal. Where are they? Here's one. Oh, here's two. In my dirty
We're gonna
bag.
stop sharing so you can get nice and close.
I'm dropping shit now. Ugh. I got a red one in here too. So these are the American 1100 series that I was talking about on the serrated pin slide. Fun time, just all around. They give you a decent bit of challenge for, I think they're like, I picked this one up for like $7 on Amazon, but you really don't want to buy this stuff until you really get into it, because these are a little tougher, as I said. But yes, where's this?
The camera's pointing right
All
there.
right, let me see if I can get.
No, it's right there.
Can
It's
you-
right there.
All right, now I was just putting that there so that I could see myself a little bit here. Yeah, so this is a 1100 series. Master actually makes these, but American Lock was a different company that got absorbed by them. Something, a bunch of technicality. Anyway, let's get it. Start your timers. You hear those clicks? Can you hear them?
Yeah, you can hear him on stream.
Oh yeah. Dude, let me get it real close to the mic. Ooh, you hear that, guys? I fucking got it. Ha, that was pretty quick. Let me try another one.
Let's hit up one more and then
All right, yeah, it should be pretty quick.
show him the lock before you do it.
Show them the lock. All right, guys. Fuck, where's... All right, so I may have been off camera for that one. So as you can see, this is the lock. It's actually locked here. I don't know if you can see that. Oh, really? I couldn't tell. Anyway, so this is it. Yeah, it's locked. It's locked. Hold on here. Bear with me. I'll try to unlock it. This one actually was giving me a little bit of trouble earlier, so no promises. A lot of lock picking and stuff can be dependent on how you're feeling at a given moment, and I know for me, sometimes I'll just get burnt out on this stuff and I can't continue until the next day. So just things to consider, I guess. And also, while I'm here, you see this Peterson lockpick shirt? This is a shirt I got for free. It's a bit of a backstory behind it, but Peterson lockpicks, they make quality tools in the USA. Oh shit, false set, you see that? You remember how I was talking about false sets earlier? You definitely can't see that, but it rotated like a decent bit. So now I gotta find the serrated spool and open it for the chat or whatever. Do it for the vine. Ooh, that's good, counter rotation, and boom, open. Got him. Awesome. Thanks, guys. What'd you think?